is if they're corresponding sides, does that automatically mean that their measures are going to be equal in similar figures? No, right? Just because they're corresponding sides does not mean their measures are going to be equal. In fact, their measures aren't going to be equal because similar means it's a different size. So here, like if we said side 6 corresponds to side 3, that is a true statement. Those are corresponding, but their measures are not equal. 6 is not the same size as 3. So that one's tricky. Don't miss it on your test. Just because they're corresponding does not mean that the measures of the sides are equal. So that one is a false statement. Give yourself a pat on the back if you got that right. That was a tricky one. All right, so another one that we're pretty split on. We're not really sure if that's true or false. Anybody want to take the mic and defend themselves? All right, Nathan, go ahead and let us know what you think.
T cannot correspond to E because T corresponds to G. It was the first statement, and a lot of us agreed it was true. So this last statement, claiming that T corresponds to E, cannot be true.
Okay, interesting. So he said there's not even corresponding parts, right? T is the first letter and E is the last letter. They don't correspond. So of course they're not going to be true. It's going to be false. Okay. Yeah, they are part of the same figure, but they are not corresponding sides. Good way of saying that. All right, so we're going to move on. So we're not going to take as much time on this one. I'm just going to go through it quickly. But you guys are awesome at corresponding sides now. We've done it so much that I feel really confident. So I'm going to turn the whiteboard tools on, and I just want you to write down angle T corresponds to what? Angle I corresponds to what? Side TI goes with what? And side RI goes with what? This is on the whiteboard, but we have enough correct ones that we're going to go ahead and move on. Nice job. T does correspond to G, so that's correct. I is the last one. E is the last one, so that's correct. TI is the first and the last, so it goes with the first and the last, which is GE. That's correct. You guys are killing it. And then RI is the last two, so it corresponds to LE, which is the last two. Really? Is that somebody's nickname? No. All right. And then we want to complete the similarity statement. All that means is that you have to get it in the right order. You got to put the corresponding things with the corresponding things. So in the chat box, which one goes with letter A? Yeah, letter D. You have one angle marking here and one angle marking there, so those have to go together. What corresponds to B? E, yep, 2 and 2. And then, of course, C goes with F. Now, please don't just assume, I know this is kind of a bad example, but B was on top and E was on top. Don't assume it'll always be that way. Check the markings, because they can rotate the figures, so make sure you check the markings. All right. Let me change your folding tools. Hey, our participation is getting better. Thanks, guys. Love to see that. Love it. Okay, so it looks like we're thinking C. Anybody want to tell us how they got C? I'll turn the chat box on if you don't want to grab the mic and you just want to type it in the chat. But if you do want to grab the mic, go ahead. All right, I'm gonna let Nathan go ahead.
At this point, it's just easy. You're going to add up the two angles and subtract the answer to that from 180. 180 is the answer to the first one. Okay.
Hey, how did you guys know to use 180? I'm seeing great answers in the chat box. Where did you guys get the 180 from?
Because you know that all angles, not all angles, these angles equal 180, and you use the formula that is given.
Yeah, anytime you have triangles, they always add up to 180. So yeah, you can just do what you do, add them up and subtract from 180. Awesome. Good job. Okay, the last one for the Unit 6 review. And it says rectangle RECT is similar to rectangle ANGL. Let's see what I did there with the letters. I'm such a dork. Okay, what is the scale factor of the dilation from rect to angle? Oh, so we're torn. A is kind of winning, but we're kind of torn between A and C. So, let's check it out. So it's important. The order is really important here. So it says, what is the scale factor of the dilation from rect to angle? That means that we start with RECT, that's our pre-image, and we end up with ANGL. So we're starting with a bigger one, and we're ending with a smaller one. The order does matter. If we start big and we get smaller, we know that we're going to be shrinking it or contracting it or making it smaller. So we automatically know that our scale factor has to be less than 1. So I'm going to get rid of C and D. All right, so that order is important. Let me turn the chat on. Sorry, I thought the chat was on. So make sure when you do a scale factor problem, you know which one is the pre-image and which one is the image, so you can tell whether you're getting bigger or smaller, because that does make a difference. So all of you that put C, you kind of have the right idea. You were just going in the wrong order. And then to find out whether it's A or whether it's B, we're just going to pick corresponding sides. So I'm going to do RE corresponds to AN. So RE is 12, AN is 4. Image over pre-image equals 1/3. And the scale factor formula, just in case you forgot, I know I said it, but I didn't write it down. Scale factor is image over pre-image. Okie dokie.